Hello class, welcome to our lesson today dealing with comparing populations. We're going to be looking at some different graphs and how to compare them. You want to make sure you pay attention to what the directions are asking you to do on some of these questions. So let's go and get started with a review question that's dealing with solving equations again. So remember, when you're solving equations, you have to make sure that you get all of the things with variables together. So this 5x minus x, so that's 5x minus, remember, 1x. If there's no coefficient, it's implied it's a 1. 5 minus the 1 would be 4x. And then from there, it's just a two-step equation. Remember, to get rid of plus 3, you have to do minus 3. Negative 14 minus 3, those are both negatives. So you should add them together, and it's negative 17, then divide by 4. Obviously, you can make that a decimal if you want to. I'm just showing that it's also an improper fraction than becoming a mixed number. For the question on the right, you might find it easier to divide by negative 3 right at the beginning. If that divides nicely with the right side, I might suggest that. From there, it's just a matter of solving for x, so adding 8 to both sides, then dividing by 4, and you should get x equals 7. Remember, the goal here is that you work backwards to solve these questions. You don't want to be guessing, checking your way through these situations. You want to make sure that you're working through them in order to figure out what the correct answer is. Okay, when we compare two populations, there's two ways that we can look at it. First off, if both distributions are symmetric. Now, by symmetric, we mean there's a small amount of data on the side, lots of data in the middle of it, and then small amount. And you'll see what I mean by that in a little bit. We're going to use the mean and MAD to compare them. When the data sets are skewed in one way or the other, which means there's a lot of data on one side versus the other, or we don't really know anything about the mean, or we can't find it, then we can use the median and IQR. We'll go through some examples of both versions to make sure that we can see it, and then be able to compare them using the difference between them. Okay, so here's a double dot plot. Now, this is the idea of a symmetric graph. Okay, so if you look at this first one, see how it starts low, kind of goes higher. Most of the data is here in the middle and then goes back down. There is some leeway in terms of what it looks like, but even though there's 3 here, it's still starting smaller, bigger in the middle, and then back down. Yeah, it kind of has this extra piece here on the left side, but in general, that would be a symmetric graph. Because of that, I'm going to find the mean. Okay, now I'm going to go into detail about how to find the blue one, and then the red one, we'll just trust that this is the answer. For the blue one, what I would do to find the mean is take each of the dots and add them all together. So 50 plus 60 plus 60 plus 70 plus 70, etc., all the way through, and then divide by 15 because there's 15 numbers. I get a mean of 84. The MAD is found by taking the difference from 84 to all the numbers. So from 84 to 50, if I take 84 minus 50, that's 34. If I take 84 minus 60, that's 24. 84 minus 70, that's 14. 84 minus 80 is 4. And I keep going through and doing that on every number. So like 120, remember when it gets past the mean, you got to do the opposite. So it'd be 120 minus the 84 to see what's left to add to the MAD. I add up all those numbers. I still divide by 15 because it's the mean, the average of the deviations. And so that would end up being about 16.3 or about 16. Candidate B has a mean of 58 if I go through the same process, and a median of 15.7, which is also about 16. So they have different measures of center. Okay, so the means of the first one and the second one are different, but their MADs, which is a measure of variation because it's deviation from the mean, their MADs are both about 16. What this is saying here is that candidate A and B, they differ in how long they talk in a similar fashion. However, candidate A seems to be talking longer than candidate B when answering the questions. Okay, the important thing about one style question on your homework is you're going to see this version. Express the difference of the measures of center as a multiple of the measure of variation. All this is find the difference of the measures of center. So the difference of the means, so 84 minus 58. If we want it as a multiple of the measure of variation, I just divide by the the MAD, the mean absolute deviation. So I just divide by that 16 and I get 1.6. Which shows the difference in the means is 1.6 times the MAD. The key is the larger this number becomes, the less overlap there is of the data set. So if the blue candidate was even further over compared to the red candidate, what we would say here is that that the difference of the means would be even more times. So the larger that number becomes, the more spread out comparatively candidate A answers and candidate B answers are. That's not going to make a ton of sense right now. If you can at least find the number, then that's probably the best case scenario. So express the difference of the measures of center as a multiple of measure of variation. You find the difference of the measures of center, the means, then divide by the MAD. If the MADs are slightly different, you could just pick one of them or you could average them. I kind of averaged my two and then said it was about 16. Maybe if you go to the nearest whole number, that would be fine for now. It shouldn't matter which MAD you pick. Okay, now what if we increase everything of candidate A 45 seconds? So I increase all of candidate A's answers by 45 seconds. That's going to affect the mean because all the answers are increased by 45. And in fact, it would probably increase the mean by 45. The MAD, though, would not be any different because all my numbers moved in a similar fashion. And so they all deviate from the mean in a similar way. So all it would do is say that the candidate A's average or mean is even larger than what it was before. Okay, now that we've done a mean and MAD question, median and IQR questions are actually a little bit easier because typically they give you box plots with them. Okay, so it says a double box plot, double because there's two of them, shows the random sample of 10 speeding tickets issued in 2 states. So compare the measures of center and variation. So the median, remember, is the line in the middle of the box plot, is 70. The IQR is the end of the box plot minus the other end of the box plot. So 80 minus 60 is 20. So the state A has a median of 70 and an IQR of 20. State B has a median of 80 and an IQR of 30 because 100 minus 70 is 30. So comparing them, we could say, well, it seems like it costs a little bit more in state B. And the variation is a little bit more in state B because it's 30 versus 20. The problem here is it's only 10 speeding tickets. You'll notice here that the highest speeding ticket in state A is actually higher than the highest speeding ticket in state B. But that could just mean that this person was going really, really fast compared to the person in state B. It also could mean maybe there's multiple offenses, whatever it is for the speeding ticket. We can't really say a whole lot because it's only 10 though. However, what if I took the medians and basically averaged out 100 samples of 10? So now I'm looking for the average of the middle number of 100 different groups of 10. Now I've increased my sample size tremendously. If we look at that, the median of state A is around 65. And again, I'm kind of estimating here. And the IQR is about 10. It's probably a little bit larger than 10. It looks like it's a little bit higher than 70 here and it's 60, but it's about 10. The median for state B is 80, and the IQR is also about 10. If you look at the boxes, the key with the boxes are that they're about the same width. The box for A and B are about the same, which makes sense because their IQRs are about the same. The medians, though, the state B median is around 80, the state A median is around 65. And the key here is now we can probably say that state B's tickets are more expensive. Mainly because the entire box of state B is higher than the entire box of state A. There is no overlap of the boxes. Now that's not saying that there are going to be higher and lower values, but those could be outliers or very strange situations. Okay, or just someone was going just barely over the speed limit versus really far over the speed limit. Okay, so there's going to be some overlap of some of the data, but where the bulk of the data, which is where the box is, there's no overlap. Which we can probably safely say then that state B has more expensive speeding tickets, or maybe there's more patrols out, or maybe there's certain rules and regulations that are in place. Maybe there's some reason for it, but state B appears to have more expensive speeding tickets. If I take that information and then I want to express the difference as a measure of as a multiple of the measure of variation, remember, I find the difference of the measures of center, so subtract the two medians, and then divide by the measure of standard of deviation or variation, which would be the IQR. So 80 minus the 65 would be 15, divided by 10 would be 1.5, which means the difference of the medians is 1.5 times the MAD. Again, this idea may not make complete sense right now. It probably is different in each situation, but at least you can go through the process of that sentence and say, express the difference, all right, subtract, as a multiple of the measure of variation, which means I need to divide by that to figure out how many multiples of it that I have. Again, your conclusion here would be state B has more expensive tickets, it seems, because its entire box of the box plot is higher than state A. Okay, when you do your homework, you have questions 1 and 2 and the questions 4 through 9 on 10.7. Remember to skip 9B. And when you do express the difference of the measures of center as a multiple of measure of variation, it's the difference of the measures of center divided by the MAD or the IQR, depending on the question. You have examples of both versions here. Okay, so you have one that deals with MAD and mean. Those problems take a while. You're going to have to show a little bit more work on those ones. The IQR and median questions will take a little bit less work because you don't have to find the means and find the MADs. The IQR and median are actually much easier. So those box plot questions should actually take you a lot less time compared to the mean and MAD questions. Remember, for your upcoming test, you have to understand how to find all of these things on your own. So if you have questions on that, make sure you ask your teacher. Have a good day, everyone.